Okay, functions advanced problem 2. I've gotten a lot of questions about this problem for good reason. It's a tough problem. Most of the questions are about parts 2 and 3, but let me do part 1 because part 1, done the way that I'm going to do it now, is a model for how to do parts 2 and 3. Okay. All right, so our function is v of t equals 320 e to the negative 3.1 t. Okay, so we're asked how to, in part 1, how to find or define how much time elapsed from the voltage being 200 to the voltage being 100. Okay, this is our voltage at time t. So first, let's find the amount of find the exact time that the voltage is 200. Then we'll find the exact time that the voltage is 100, and then we'll subtract, and we'll find the time elapsed. Okay. All right. So 320 e to the negative 3.1 t equals 200. And when we solve for t, this will tell us when the exact time that the voltage is 200. Okay, so let's see, divide both sides by 320 e to the negative 3.1 t equals 200 over 320. To get the t out of the exponent, we use natural log. Natural log undoes the e, the exponential. All right, so we have negative 3.1 t equals ln 200 over 320. Divide both sides by negative 3.1 t. Oh, no t there, sorry. Divide both sides by negative 3.1. My mistake. Okay, t is 1 over negative 3.1 times ln 200 over 320. Plug that into your calculator. You'll see that that is approximately 0.1516. Okay, this is the first time, so I'm gonna label it T1. Okay, so let's put that. Let's save that over here. Let's say T1 is 0.1516. Okay. Now we're going to solve for the time that gives a voltage of 100. All right, through similar calculations, we get that time. Now, since that's the second time, let's call it T2. This we find is about 0.3752. Okay, so T2, 0.3752. Okay, so now how much time did it take to get from T1 to T2, right? Because how much time did it take to get from a voltage of 200, which is this time, which happened at this time, to a voltage of 100, which happened at this time? It's T2 minus T1. So let's see, that minus that, and you get, this is approximately 0.224. Right, so that's your answer to part 1. All right, now we're going to do almost exactly the same thing but with the x and 0.5x for part 2. Okay, now part 2. So first we set our function equal to x, voltage x, and we solve again for t. All right, dividing by 320, we have e to the negative 3.1 t equals x over 320. Taking the natural log of both sides, right, this is the first time, right? First time, so we'll label that T1. All right, so I'll label that T1. Okay, and now, same thing, but we'll set it equal to 0.5x. Okay, solving for t again through similar calculations. We find that t is equal to negative 1 over 3.1 ln 0.5x over 320. All right, so this is our second time, so we'll label this T2. Okay, and we want to know the time elapsed. The time elapsed is going to be T2 minus T1. All right, so we compute, say, T2 minus T1. Okay, so what do we got here? T2, as we found right here, we got negative 1 over 3.1 ln 0.5x over 320 minus, so minus T1, which is this guy here. Let's see, it's minus 1 over 3.1 ln x over 320. So, okay, so first of all, notice that we have a negative 1 over 3.1 in common to both pieces here. So let's factor that out. Ln 0.5x over 320 minus ln x over 320. Okay, now I'm going to use a little trick or a formula from pre-calculus. This formula is ln a times b is ln a plus ln b. So this might be, this is the log product, the product rule for logs or something. Anyway, ln of a product is the ln of the sums, is the sum of the ln's. Okay, all right. And the thing to notice is that x over 320 here, we have an x over 320 there. So we're going to think, how can we manipulate this with this formula to pull out the ln x over 320? Okay, so notice here that this can be written as 0.5 times x over 320. So 0.5x over 320 is the same as 0.5 times x over 320. Right, so using our rule here, we can write this as ln 0.5 plus ln x over 320 minus ln x over 320. You see that these guys cancel. And if you plug this into your calculator, you'll see that you get the same answer as part 1. So the thing to notice is in the first one, the voltage we started with was 200, and the second voltage was half of that, 100, right? And so here, this problem, we're doing exactly the same thing, but in general. So the first problem is a specific version of the general second problem. Now your third problem on this one, what you're going to do, or the third part on this problem, what you're going to do is almost exactly the same as I've done here for the second part, except for instead of starting with 320e to the negative 3.1t equals 0.5x, you're starting with, the second, you're using 320e to the negative 3.1t equals 0.1x. All right, good luck.